So this time it might actually be useful to just go ahead and subtract lambda times the identity from the matrix. And then you end up with this right here. Now, under what circumstances is a diagonal matrix singular? It is only singular if there is a 0 on the diagonal. And from that you conclude that lambda equal to 3 is an eigenvalue and lambda equal to -1 is an eigenvalue. And if you then look at the matrix 3 minus 3 minus 1 minus 3, 0, 0, notice that that's the matrix 0, 0, 0, minus 4. And for what vectors is that true? Well, that's true for any vector that is a multiple of the vector 1, 0. So we might want to settle for the eigenpair 3, 1, 0. And then if you do the same thing but with lambda equal to -1, you end up with 3 minus, -1, 0, 0, -1, minus, -1. And you end up with the matrix, let's see, 4, 0, 0, 0. And if you ask the question, for what vectors is this true? You end up finding the eigenpair -1 and, for example, the vector 0, 1. So this is an eigenpair and this is an eigenpair. So let's visualize what happens when we have a diagonal matrix, and in this case the diagonal matrix has values 3 and -1. Let's run this for a little bit and then let's discuss it. So here we see the thick red vector pointing to points on the unit circle, and that's the vector x. And then the result of doing a times x is being plotted by the thick blue vector. What we're interested in is when those vectors point in the same direction. Well, notice that the red vector x and the blue vector a times x point in opposite directions, and if you look at it, it sure seems like a times x is of the same length as x is. That is because x is an eigenvector, and the eigenvalue associated with it is -1, and therefore when you do a times x with a vector x that points in the direction of the eigenvector associated with the second eigenvalue here, -1, all it does is it flips x in the opposite direction. So what's important here is that the result of doing a times x is exactly the same as multiplying x by the scalar -1, as long as x is in the direction of that eigenvector. Now if we go on, we notice that when x points in the direction of the first eigenvector, x0, which is associated with the eigenvalue 3, then again x and a times x point in the same direction, except that a times x is now exactly the vector x multiplied by 3. So here's another homework, and the question is for you to identify the eigenvalues of a diagonal matrix. Notice that you've seen some examples now, and maybe from those examples you can extrapolate. You will see me in the next video.